Okay, hi everybody. Today we're going to be looking at lesson 3 in your grade 9 review. So we are actually going to take a look at solving equations. So in the previous lesson we looked at just simplifying equations, either by eliminating a fraction or distributing or expanding and simplifying. So today we're going to kind of combine all of that and then use the process of algebra to actually solve those equations. So when we think of an equation, we should think of it as a statement of equality, meaning that we always want to make sure that the left side of an equation is equal to the right side of the equation. It's best if we think about this in terms of it as a balance. So think of it as a balance, where you might put something on either side of the balance and you want to make sure that it is level, right? It doesn't tilt one way or the other. So if you think about what a balance looks like, kind of has a levy here, and then you have a scale on one side and you have a weigh scale on the other side. Not an artist, just a math teacher, right? So you want to make sure those are level. You don't want them to tip one way or the other, because then the equation is not balanced. It's not exactly the same on the left as it is on the right. So if you kind of translate that to an actual equation, to solve an equation means that we're trying to find a value for the variable or for the letter part that makes the statement true. So when we're talking about the variable, we're talking about this letter part here, the x, right? So this is saying that the left side equals, I'm just going to erase that because the arrow is right in the way there, the letter part. The left side of the equation equals something, and the right side of the equation equals something. And those two somethings should be the same. Well, it's saying on the right side of the equation is negative 13. So if the right side of the equation is negative 13, then that must mean that this entire expression on the left side, this must equal negative 13 as well. So our job in terms of math is using this process of algebra to figure out, okay, what does x have to be to ensure that the left side of the equation is also equal to negative 13? Because that equal sign is telling me that both sides of these equations have to equal negative 13. Okay, so an equation can be solved by isolating the variable. So what that means is that we're going to remove all the other numbers that are on the side with the variable in order to figure out just what x is. Because if we can move everything else away from it, then we're going to be left with x equals some value. So to isolate the variable, we are removing all other numbers that are on the same side as the variable. And we're going to remove them mathematically, or use algebra. Okay, so we move those with this process of algebra that you would have seen lots of last year, and we're going to review it in the rest of this lesson. So just keep in mind that whenever we are isolating that variable, we're basically trying to figure out the solution of the equation. Okay, so another name for the solution of an equation is also called the root. So those two words can be used interchangeably. So someone might say, okay, what's the solution to this equation? Or they might say to you, what is the root to the equation? Those statements mean the exact same thing. So let's take a look at when we just have a one-step equation, and then we'll get into more complicated ones. If we have a plus 2 equals 7, well, it says that in order to solve this, as we mentioned above, okay, we need to isolate that variable, right? So we need to isolate that variable by removing all the other numbers. So we need to remove that positive 2 from that left side of the equation. So the way that we're going to move it is we're going to subtract it. Okay. Last year we would have talked about when we're moving things to the other side of the equation, we want to do the opposite operation to move that. So to move the 2 over to the other side of the equation, because right now it's a plus 2 on the left, to move it over to the to the right side of the equation, we're going to change it to a minus 2. So we're left with a equals a negative 9. So once again, just to make note of what we're doing, we're going to subtract 2. and we subtracted it from the left side, so we had a positive 2 minus 2. That's how it went away from the left side. So we have to make sure we do it to the right side as well. So we're subtracting 2 from both sides. Remember, this is that whole algebraic idea of doing the opposite operation. Okay, so in this second one-step algebraic equation, we have 2w equals 16. So if it's 2 times w, we're going to divide both sides by 2. Remember, we're trying to get that w by itself, so we have to get rid of all the numbers that are on the same side as it. So we're going to divide both sides by 2. So that makes the 2's on the left cancel out, so we're just left with w. And then 16 divided by 2 is 8. Okay. That's for our one-step equation, where we really just had one number to move. If we look at these next few examples, we actually have 2 numbers to get rid of on the left side of the equation, or on the side of the equation where our variable is. So we have 5x minus 6 equals 31, or sorry, equals negative 31. So we have to start thinking about, okay, well, I need to move a 6 and I have to move that 5. So the real question here should be, which operation is performed first? Okay, and we have a rule in terms of when we are trying to combine different operations, when it's just a straight arithmetic sentence. In this case, though, we're kind of reversing or undoing all of that. So usually when we have arithmetic that we're trying to figure out what comes first, we use BEDMAS, right? We use those order of operations. But since we're undoing it or moving everything essentially in the reverse order, then that is the way that we are going to move everything algebraically. We are going to do BEDMAS in reverse order. So we're going to reverse order our BEDMAS. So that means we're going to start with any subtraction and addition, and then we're going to multiply or divide, and then we're going to deal with exponents and brackets. So we're going to reverse order our BEDMAS. So for this equation here, we have 5x minus 6. Okay, so we're going to deal with any addition and subtraction first. So if we have a minus 6, we know to move it we have to add 6. And then we're going to deal with any multiplication and division after that. So we have a 5 times x. And so to get rid of that 5, we need to divide because it was being multiplied. So we're going to add 6 to both sides. Let's try that again. We're going to add 6 to both sides. And then we're going to divide by 5. Okay, so my 5x is staying on the left for now. I'm going to add 6 from my negative 6, so those are going to drop away. And then I'm going to make sure I add 6 to the other side of the equation. So we'll have 5x equals negative 25. Then we'll divide both sides by that 5 to clear that 5 out of the left side. So those 5's will cancel out on the left, and we'll be left with x equals negative 25 divided by 5 is negative 5. Okay, take some time and see if you can figure out that equation right underneath. So the 9 minus 2p equals negative 5. I'm going to pause the video. So pause it now and see if you can try that equation. So there's the solution to the next one. If we had a positive 9 minus 2p equals negative 5, we're going to first add, we're first going to take that positive 9 and subtract it from both sides. So we'll subtract it from the left to get rid of it, and then we'll subtract it from the right. So you'll have a negative 14 on the right, and then we'll have to divide by a negative 2 to clear that negative 2 from the left side. So you should be left with p equals 7. Let's take a look at a few more examples that have to deal with fractions and see if we can first solve those. So this first example here, I'm just going to switch colors so we don't get messed up. Okay, we have a plus 5 and we have a divided by 2 here. So I'm going to first take that positive 5 and subtract it from both sides. I'm going to have m divided by 2, subtract plus 5 minus 5, those cancel away, and then it equals 8 minus 5. So we'll have m over 2 equals 3. And now since we have m divided by 2, we'll just have to multiply by 2 to clear it from that left side. So those will cancel out, and you'll be left with m is equal to 6. Okay, that one's a little bit more straightforward, but when you have two fractions you're dealing with like you do in that next one, we're first going to have to take a look at our lowest common denominator, just like we did in the previous day's lesson. So we have a denominator of 4 and a denominator of 2. So in this case, our LCD, or our lowest common denominator, is going to be 4. So we're going to have to multiply everything by 4. So we're going to have 34 over 4 times 4 equals b over 2 times 4 and 3 times 4. This will help us clear that fraction. So in this first one, 34 over 4 times 4, those 4's will cancel out, and we'll just be left with 34. Makes it much easier. Okay, and then we will have the 4 times b over 2. The 4's and 2's will reduce to 1, so you'll just be left with 2b. And then 3 times 4 is a minus 12. Okay, so from there we should be able to simplify or do some rearranging while we simplify. So I'm going to add 12 to both sides. So I'm going to, 34 plus 12 is going to be 46 equals 2b. And then finally we got to clear that 2. So we're going to divide both sides by 2. I'm just going to finish it up over here. So those 2's will cancel out on the right, and you'll be left with 46 divided by 2 is 23, is equal to b. Okay, so we're going to look at a few more different instances of equations, and we'll do a little bit of I try, you try. So what to do when we have variables on both sides of the equations. So when that's the case, just kind of rule of thumb, and it might change depending on where you have pluses and minuses, but if it doesn't make much difference, it's always a little bit easier to get all the letters on the left. So we always say letters on the left and numbers on the right. Because we tend to read things like x equals 5 or y equals 6, right? So we kind of generally, as we're reading it, we read it letters to numbers. So when we're trying to simplify equation, I'm going to try to move all my variable or my letter stuff to the left and my number stuff to the right. So I have 2x minus 3 equals x plus 4. So I'm going to move my x's to the left and my numbers to the right. So I'm going to keep my 2x, but I'm going to try to move this x over here. So since it's a plus x on the right, to move it to the left, I'm going to make it a minus x. And then I'm going to have equals 4, and again, I'm going to move this 3 over to the right. So since it's a minus 3 on the left, it's going to become a plus 3 on the right. So 2x minus x just equals x, and 4 plus 3 equals 7. Okay? Go ahead and pause the video and see if you can follow that process to solve the next one. C plus 7 equals 4c minus 62. Okay, so there's the solution for the next one. We got all the c's to the left, we got the numbers or the constants to the right, and then we had kind of a one-step equation to simplify to c equals 23. So we'll take a look now at how to deal with if we have brackets. We're going to distribute or expand like we did in the previous day's lesson, and then use what we know about algebra to solve. So in this first equation, we have negative 12 equals 2 times m plus 5. So we're going to have to expand or distribute that 2 inside of our brackets. So we're going to leave that negative 12 alone for now. We have 2 times m is 2m, and then 2 times positive 5 is a plus 10. And now our algebra, same process. Okay, we want to move everything from away from the side with our letter. So we have that 2m plus 10. I'm going to start by subtracting 10 from both sides. So we'll have a negative 12 minus 10 equals 2m. Negative 22 equals 2m. And then we got to get rid of that 2 on our m. So we're going to divide both sides by 2. And we'll have a negative 11 equals m. Notice in this case, we do have the m, or we have our variable on the right-hand side. It doesn't matter. We can still read it that m equals negative 11, or we can read it negative 11 equals m. Those two things mean the same. So don't worry too much which side that letter ends up on. Go ahead and pause the video and see if you can try the next example with brackets. Okay, so there's the solution for the next one with brackets. We again expanded and simplified, and then we use our algebra rules about getting all your letters on the left and your numbers on the right to solve for y. Okay, the last type of equation we're going to look at today is any type of fractional equations where we're trying to solve or find the root of the equation. So when we have our fractions, again, we're going to try to get rid of the fraction part by identifying what the lowest common multiple is, or lowest common denominator is, and then multiplying everything by that. So this first equation we have here, we have 4/5 equals x times 20. So our lowest common denominator is going to be 20. So we're going to multiply everything by 20. Even though that second fraction already has a denominator of 20, if we do something to the left side of the equation, we have to make sure we do it to the right side of the equation. Okay, so if we have 4/5, we're going to multiply that by 20. And we're going to take that x over 20, and we're going to multiply that by 20. Okay, so 20 times 4/5, well, we can simplify that a little bit, because 20 and 5 are going to reduce to 4. And then on the right-hand side, we can reduce those 20s, right? They're just going to cancel each other right out. So you're going to have 4 times 4 is 16, which equals x. Okay. When you have just a simple fraction on one side of the equation and a simple fraction on the other side, you can eliminate your fraction by multiplying by that lowest common denominator. There is another choice as well. Okay, so I'm just going to put this over here and write or. The other option is to do a process you would have learned about in grade 9 called cross multiply. Because cross multiply is basically performing that algebraic operation for you, right? Where something was being divided, it's now being multiplied. So you are just playing around with that, moving things to the other side of the equation. So if we took 4/5 equal to x over 20, and we cross multiply, that means we're going to take the top of one fraction and multiply it by the bottom of the other. For example, I'm going to take 4 and I'm going to multiply it by 20. So we're going to multiply kind of on a diagonal. So 4 times 20. And then we're going to take 5 and multiply by that x, so 5x. So 4 times 20 is 80. It equals 5x. And then same process now. We're wanting to eliminate the 5 next to the x. So we're going to divide both sides by 5. And you're going to get the same answer. 16 is equal to x. So when you have a really basic fraction on either side, you can either eliminate the fraction with your lowest common denominator, or you can multiply. Okay, let's try the one right below that, and then we'll move over to the right. So the one down below, we have this b over 4 equals b minus 2 over 3. So once again, those are pretty simple fractions. We could cross multiply, or we could multiply by the lowest common denominator. So just to stick with that process, we'll do the LCD. So we have a denominator of 4 and 3, so our lowest common denominator would be 12. So I'm just going to rewrite b over 4, we're going to multiply that by 12. And we're going to have b minus 2 over 3, and we're going to multiply that by 12. Okay, so again, the 12 and the 4 will reduce to 3 on the left, so we'll have 3b. And on the right-hand side, the 12 and the 3 are going to reduce to just 4. So we're going to have 4, and remember, this b minus 2 is in brackets. So we have to make sure that we distribute it basically inside both those parts. So we're going to have 4b, and then we're going to have 4 times 2, we're going to have minus 8. Okay, I'm going to get all my letters on the left and all my numbers on the right. So I'm going to move that 4b over by subtracting it. So 3b minus 4b is a negative 1b equals negative 8. And then we got to get rid of that negative 1. So we're just going to divide both sides by negative 1. And you should be left with b equals 8. Okay. Last example for today, and then we'll be all done. So we have y over 2 plus y over 7 equals 18. Actually, I'm going to pause this one. I'm going to let you guys work through this. Remember, find your lowest common denominator and then solve for y. Okay, so there's the solution once you identify your lowest common denominator is 14, and we solved and got that y equals 28. Okay, that's all for the note for today.